dividing are basically the same thing. So if you can multiply two radicals together, or break up a radical into two things that it's multiplied to, you can do the same thing with dividing. So if you have an entire radical that has division inside, you could break it up and have that same radical on the top with the same index divided by the radical on the bottom with the same index. So the property of multiplying, which says you can multiply two radicals together, is also true for dividing. You can divide two radicals together. Right? So I could have something that, okay, I would like you to answer the following question, mental math to 10 decimal places. I'll give you a few seconds. This sounds a little scary, doesn't it? Okay. Oops. In your head, think about the square root of 50 only to 10 decimal places. Right? Square root of 49 is 7. So this is going to be 7 point, just do the mental math quickly in your head and get 10 decimal places. Then I'd like you to think about the square root of 2, 1.41, so. Keep 10 decimal places of that. And now take your number with 10 decimal places on the top. Take your number of 10 decimal places on the bottom. Divide them. And give me an exact answer, or at least to 10 decimal places, without a calculator. What's the answer going to be?
The square root of 25.
Which is? To 10 decimal places? You can't do the square root of 25?
Oh.
Oh, it's 5! Wow, you're amazing! That's phenomenal. You did those 10 decimal places there, and those 10 decimal places there, and you got 5 perfectly. You guys have an amazing feat of mental math. Well, because we can do this, right? And then that leads to this, which leads to that. I kind of, right? Some of you, when I said to 10 decimal places, some of you, I could see in your eyes, you just like, I'm giving up. I saw that. Right? You have to realize that as a teacher, I'm going to trick you all over the place. You have to be on your toes in this class. Because I'm going to throw things at you that you'll be like, well, wait a minute, is this a trick? Or is he being serious here? Because this was not hard at all. Right? You didn't need to know square root of 50 to 10 decimal places. Or the square root of 2 to 10 decimal places. Because when we divided them, it ended up being something nice. All right, so now we can do example 2. And in example 2, we have, right, the definition of a mixed radical again. So we need to know our powers chart. And in A, it's a cube root. So in our powers chart, which you can still see because it's at the top of page 96, you're looking for your perfect cubes. And we can, to make our life easier, maybe I start off by just looking at the top and bottom separately. Is there a perfect cube that we can pull out a 16? What's your first perfect cube? Is 1 cubed is 1. That one we don't worry about. 2 cubed is 8. You can divide 16 by 8? Yes. So we can put the 8 here. And technically you can put the negative either with the 8 or the 2. I'm going to put it with the 8. Cube roots, you can do negatives of. Square roots, you can't. Even roots, fourth roots can't do. Fifth roots, you can have a negative. But sixth roots, you can't. What about 135? Does 135 divide by 8? So then the next perfect cube on your powers chart is 27. Does 135 divide by 27? It actually does. So having, like, you see how I'm using just the perfect cubes to check? I didn't worry about breaking up 130. Like, it's obvious that 135 divides by 5. But I didn't even try that because it's not a perfect cube. It happens to be that 5 worked out nicely with the 27, but you try only your perfect cubes for simplifying. This becomes -2 cube root of 2. Cube root of 27 is 3 cube root of 5. I can put my number together as -2/3. I can put my radical together as 2/5. And this is a mixed radical. A mixed radical has a number in front and a radical after in simplest form. B, we want to write as an entire radical. I'm going to just make a note here. Careful with negatives. If the negative is outside and it's a cube root, a fifth root, any odd root, you can put the negative inside. If the negative is outside and it's a square root, a fourth root, any even root, you can never put a negative inside of a square root. So in this example, this negative is going to stay on the outside. But the first thing we're going to do is we're going to change our 3 to a fourth root. Again, we go to our powers chart. 3 to the power of 4 is 81. I can make that 81 over 1 because you're allowed to multiply radicals, and we can multiply fractions by multiplying the tops and multiplying the bottoms. 81 times 2 is 162 divided by 27. Is this in lowest terms? No. Okay. So now you would have to reduce 162 divided by 27, which happens to work out nicely to be 6. Again, I'm going to show you some things in math that might make your math easier. For example, I'm pretty sure none of you have memorized your 27 times table. Anybody? Right? Did you see 162 and went, oh, 27 times 6. It's on my times table. No, we usually don't go past 12. Not bad if you know your times table higher, that'd be awesome. But usually don't know it past like 12 or 10. Okay? So probably this wasn't easy mental math for you. I will say this is easier mental math, especially if you have your powers chart memorized. I know this is 3 cubed. I know this is 3 to the 4th. If I do 81 divided by 27, that can simplify it just to be a 3. I think that's easier, because now what would I have? I'd have 3 times 2, that gives me 6. That's easier mental math for me than having to do 162 divided by 27. So when you're multiplying and dividing, you have some options for simplifying, and sometimes simplifying early can make your math life easier. As a math teacher, I shouldn't tell you things like that. I should be like, make your life more difficult, right? You do more math if it's more difficult. No. Part of the fun is when you find out, oh, I can do this easier. So, questions you can circle for this one. 3, 4, 7, and 8.